Alright, so today I'm going to present on electroencephalography and how it can control a wheelchair or robotic arm. So a little intro and background is that new technology is providing disabled individuals with the ability to control wheelchairs and robotic arms, and this is something that's not completely new, but it's an idea that we want to enhance and make better. So, in the past, studies have focused and found success in allowing paralyzed patients to control their robotic arms through electroencephalography, which is the recording of the brain's activity. But we'll go into a few of the problems that researchers have found and how this specific study will help the future of research. So, why does this matter? So the study of EEG is the pathway to the future of neurotechnology and allow for patients that have suffered traumatic brain injuries to regain their quality of life. So some of the problems that we've seen in the past is that all brains are a little different, so it makes it hard to be able to record and transmit these brain readings. And there's bulky equipment that's required to be able to get these readings, and that it's very expensive for an individual who's suffered a traumatic brain injury to be able to pay for all of the equipment that's necessary. So this study and how it fixes and helps with some of these problems are that they've improved the design through a highly flexible pair mounted electrodes and an ultra-thin nanomembrane electrode and flexible circuitry connected to Bluetooth. So as you can see here, in the past, a lot of people had to have their full brain covered, but now we're looking to make it a lot more affordable and smaller to make it easier for patients. So the dry electrodes adhere to the skin and do not use an adhesive or a gel. And this system creates ease of use and reduces noise and interference to provide higher data transmission rates compared to existing systems. So, to continue on how this study is being implemented and why it's important, that the patients, they had to classify things that they would see every day, such as dogs and cats. And this information was used to study the EEG in the human brains. And they found in their model that they were able to detect specific areas of the brain that they could use these electrodes and really pinpoint where they needed to be. So some of the success that they found is obviously they were able to allow their subjects to control an electric wheelchair and a small robotic vehicle through EEG. They were also able to use a keyboard and a joystick without a controller. And typical EEG systems must cover the majority of the scalp. However, this miniature wearable device is fully integrated and designed to be comfortable for long-term use. So some of the implications is that the future patients that have suffered traumatic brain injuries are going to be able to control prosthetics and wheelchairs, and that this technology is going to become more readily available because it will become cheaper as you can use fewer electrodes. Some of the flaws in this certain study was that it has not been tested on disabled individuals and that there was only 6 subjects that were tested during this trial. So for future study and future research, they will include improving the electrodes and making them more user-friendly by making them smaller, making them easier to attach, and to really support the lifestyle of those who have suffered traumatic brain injuries. And the study of EEG can have a lot more implications in such as virtual reality and in therapeutic settings to help those who have suffered traumatic brain injuries. And then these are the articles.